Hi, good evening. And today is the 11th of July. Yeah, sorry, 11th of July, 2021. And every Sunday at 8 p.m. London time, we like to do a live vlog and sort of podcast from Zimmer and Peacock just for our news for this week. So we like to do a little roundup. This is our roundup for the week starting the 5th of July, 2021. And as I say, this is our sort of news, and essentially let's jump straight into it. So we've had a busy couple of weeks with webinars, and so the first thing I want to sort of touch upon this week is we did a webinar with PalmSense. So Zimmer and Peacock is probably a world leader in biosensor development, screen printed electrodes, sputtered electrodes. We're really hardcore on electrochemistry. And electrochemical biosensors and electrodes for electrochemistry. And we've also got a very sort of good, company that we interact with quite a lot. Well, not we have, but we interact with a company called PalmSense. And this week we did a live streaming webinar. Sorry, we did. We did a live streaming webinar with PalmSense where they They gave a little introduction to glucose sensing. Talked about the mechanism of glucose sensing, and hi Ali, we talked about, or we did a demonstration on glucose sensing. So I'll summarize it just very quickly. We did a webinar with PalmSense. We provided the live demo using their technology and our technology, and they did the introduction to us. So that was just some sort of news from Zimmer and Peacock regarding our interaction with PalmSense. In a similar note, we did a webinar with Electrobiosense. Electrobiosense are our distributors in Turkey, so they have a very good entrepreneurial scientist there, and he arranged the webinar and we did the demonstration. And again, we did some content for the webinar. We talked about nitrate sensors and glucose sensors, and analysis on the breath. He did his presentation in Turkish, and as multilingual as we are at Zimmer and Peacock, we did ours in English. And then at the end of it, again, we did a little demonstration using. I think we were analysing Coke, or the glucose in Coke. So as I said, we've had a busy couple of weeks really doing webinars just recently. So those are sort of some of the news from Zimmer and Peacock. I just want to say tonight I'm going to be fairly quick. I think it's mostly just Ali and I on this evening. So it's good to have Ali here. But I just want to kind of, I like to do this kind of this wrap up at the end of the week, just to really sort of touch base and sort of see, it's always busy, and it's just nice to be able to, just able to do a little sort of summary of what we've been up to. Now, Ali was there, and we actually, you might have missed it. No, Ali actually missed it, but we had a webinar this week for our ZP Developer Zone. It was really good because we got asked a couple of questions. One of them was about gold electrodes, and it was a new member of the ZP Developer Zone. They'd contacted us and said, look, we're having problems sourcing a particular gold electrode. We need some high quality gold electrodes for immunosensing. And we also need some sort of flow cell technology. And so we were able to kind of say to them, look, use our gold 303 electrode. And at the same time, if you join the ZP Developer Zone, you can download these STL files and 3D print them. So that was, and that was well received. And we also, and I think this might be interesting to Ali, also part of the webinar was actually discussing electronic tongues. And I realized that electronic tongues is probably the right time for this technology to really hit the market. I mean, people have been working on electronic noses and electronic tongues. I remember starting my PhD in 1997. I remember the lab really close to me, they were working on the electronic nose, and I realized that a working electronic nose is still not on the market. But I really think that with AI technology now, actually when you consider what the nose is a sense of sensory sort of organ, there's a sensing organ, and it's a brain that can interpret that signal. Well, of course, with AI technology, we're now mimicking what the brain does, and so if we put sensors plus AI, then we really do stand the chance of having a electronic nose or an electronic tongue. So I really would encourage people to start rethinking about electronic noses and electronic tongues. I realize, when you look at the Zimmer and Peacock, technology, if you think about the electronic tongue, people want to taste sweetness, they want to taste sourness, which is often pH, they want to taste saltiness, which is often sodium. So with the kind of sensors that we have at ZP, with the glucose sensor, the sodium sensor, and the pH sensor, you generally probably can, if you combine the raw signal with AI, you probably can make an electronic tongue application. So it's not something that we've looked into in a long time, but I'm generally starting to think this might be the right time now in the world to get back into electronic tongues. Yeah, I agree, Ali. Electronic tongues could be really useful, actually. Really useful. And like I say, it's a 30-year-old technology, but it's never really hit the market. And I think it's because AI wasn't really so available as it is now. So yeah, electronic tongue should be pretty cool. So let's jump into a bit more news. This week I'm talking to, it's not in the notes, but I'm talking to Newcastle University this week. I'm talking to their KTP, which is their Knowledge Transfer Partnership. And I'm also talking to a professor there, and we're talking about doing a KTP together. So it's a long time coming, this meeting, but we're meeting again this week. Just some news. We've moved into this new lab in Coventry. It's very exciting because it's going to provide us a hub in the UK. We've got a lot of, the plans for the UK are to have a very strong development team in the UK. We've always had a strong team in the UK, but now we've got a centralized laboratory, and to actually use it for a lot of academic interactions. I'm really, really happy with this new lab in Coventry. It's just near the University of Warwick, and there's a couple of senior academic electrochemists at the University of Warwick. So I'm really looking forward to kind of interacting with them. So this photograph that you see here is just one of our engineers called Matthew. He's just setting up a 3D printer, but it's just to kind of say that we are busy populating this new facility in the UK, with our engineers and our scientists, and they're moving their equipment in. So things are going really well on that expansion. Yes, this might be interesting to people. So at Zimmer Peacock, at any one moment, we're testing enzyme sensors, ion sensors, immunosensors, but we're also doing molecular biology, and we're doing things like PCR type assays. And so we've got a very senior molecular biologist who's managing a program for one of our clients. And so something that we've been doing is it's actually setting up a zoned system where if you do molecular biology or you're involved in it, you'll kind of know that keeping your system clean is really important. So we actually have a workflow where we have different sections, closed off sections in our laboratory, and a person can move from section 1 to section 2, from section 2 to section 3, from section 3 to section 4. But what you can't do is go backwards. And it sounds ridiculous, but we're essentially trying to prevent us going forward in the workflow and then carrying fragments of DNA back with us and contaminating the workflow. So we've had to set up, to make sure that the quality of our data is so good, or is good, we've had to actually set up a workflow, a physical workflow with essentially little tiny labs within our labs where you can only enter and you can't leave one and go back. You can't go from zone 4 back to zone 2 or from zone 2 back to zone 1. Literally, you can't go backwards. You can only go forwards. And if you've left something behind in that laboratory, you have to go and ask somebody to go and get it for you. So it sounds really just sort of draconian, but we really want to do good quality work. And in some areas of science, like molecular biology, you have to be really careful about the contamination that you could pick up and carry around the laboratories. And so we've had to set up this very zoned area. So very geeky, I know, and but this is the kind of care that you have to take. You have to take when you're doing assay development. And so, as Zimmer people go, yeah, we're busy doing assays that are quite hard, and then we're busy doing assays that are really hard. And molecular biology meets electrochemistry; those are the really challenging and fun assays to work on. Just a bit of news, Ali, you might like this. We've redone our some of our web pages a little bit now. I've always been a big fan of the value sensors. I'm always sort of promoting them because I generally think they can help people out. So we've sort of rejigged the website now, and we've brought our gold value electrodes onto one page. And similarly, if you look at our carbon electrodes, we've tried to simplify it now by saying, look, if you're interested in carbon value electrodes from us, we actually have all these different geometries. They were a bit lost and people weren't really aware that we had them, but actually we do have quite a few geometries. I always tell people, look, if you want a good ceramic substrate or carbon electrode and ceramic, then just go for our carbon 303. But some people, they want these circular kind of electrodes, and we've got them because we do a lot of work and we do a lot of electrode development. So we made sure that on the website and a little bit clearer now that you can actually purchase these things. So we've done the new page for the gold, new page for the carbon, and then the platinum. Similarly, we've put a whole page in around platinum. And so, if people say to me, I want to, I want a platinum electrode, I just tell them, go for our platinum 303. And we also have a different variant up there as well that's more square in shape. So we've just made the pages hopefully a little bit clearer, that if people are looking at a value range of electrodes, they can choose what material they want, and then under that then they'll find the various electrodes. So I think I'm getting near the end of it now. It's sometimes we go on for a long time, but this evening I just wanted to be a little bit shorter, a little bit more succinct. So I'll just wrap up with so what's happening is on Thursday I'm doing a talk with a investor network. It's a public talk. They're called Chemical Angels, and Chemical Angels have asked us to do a talk on developments and trends in biosensors. And just as part of that, I'm going to talk a little bit about, I'm sorry for the disgusting photo, but I'm just going to talk about that biosensing, the markets are expanding, the technology is getting better, and then the number of the different types of good question. And then also interested in testing new types of samples. So at ZP, we do test blood, we do test urine, we definitely test breath, we do test interstitial fluid, we do test plasma and serum, but we also test things like tear fluid, and the picture is saliva. So we are doing COVID-19 detection in saliva. Now, Ali's just asking an interesting question here. He says, are you interested in making the SPE smaller? It's a good question. And the answer is, now when you look at our SPE, I'm going to dig into this a little bit because I think it's an interesting question. So let me just dig into it a little bit. So I think what I like about the SPE at the moment is when you look at this connection here, this connection, I don't know how to describe it, but it's between the center of each pad. It's 2.54 millimeters, and that 2.54 millimeters is it means that you can plug it into our potentiostats, you can plug it into Palm Sense. It's also the same pitch that other companies like DropSense use. So there's no agreement in our industry, but several companies have independently all followed each other and said, right, let's make the pitch of the electrodes or the connection 2.54 millimeters so that we can all connect into one another. Now, the reason that I get into that a bit is Ali's just asking me the question, do you want to make your screen printed electrodes smaller? And the answer is we can make them, you're correct, we could make them a bit smaller. We could narrow it up a bit. But I don't want to make it so small that we're no longer able to use this 2.54 millimeter pitched connectors, because I feel like that should become an industry standard. In some industries, when the industry is maturing, they actually have ISO standards. You know, they kind of say, you know, the industry gets together and they say, you know, we need some rules around our industry, and so they invent, you know, ISO standards. Now in our industry, there's not an ISO standard. I think there probably will be one day, and by the way, ISO standards can take, you know, a good decade to come about. So Ali asked the question, should we make it smaller? I say we possibly could make it smaller. It'd probably be harder to make it narrower, but we could make it shorter. So quick answer is, Ali, I possibly do want to make it smaller, because if the smaller you make it, then the more efficient the manufacturing and the lower cost of the device. Problem is, I don't want to make it so small that people can't handle it. Yeah, exactly. Aftab is saying it. Hi, Ali, and hi, Aftab. Aftab's right. The problem is you then need new connectors. So I think we can possibly make it shorter, but not necessarily narrower. And then, of course, when you make something narrower, you've got to think, when you're adding liquid on one end, if you make it too narrow, you're adding liquid near the electrical connection. And so you kind of open up a new risk. So I think we can make it shorter. And every time we make it shorter, we'll make the manufacturing, let's say, more efficient. But if you make it too short, you're now asking people to make, put liquid near a connector, and if they slip, then yeah, you'll add liquid onto the electrical connections. But no, it's definitely a good question, because it's simply that, you know, if we can make, the smaller we make these electrodes, every time we print the sheet, we'll essentially have a higher density of electrodes and the lower cost they'll be. But Aftab, thank you for joining this evening. We'll have some announcements regarding Aftab in a few weeks, so look forward to the news on that. Ali, thank you for joining again this evening. You've always been a good friend to the company over the last few months, so we do appreciate it. And I will speak to Newcastle this week regarding that. And so let me summarize the news. So this week we've had a lot of webinars. We did one with Palm Sense, we did one in Turkey. We're going to do a webinar, we'll be doing them in India soon. So we're very keen on the webinars, and we've also, as you've seen, we've released, or we've updated our page on hyper value electrodes. There's a few more electrodes on there, and it should be hopefully simpler to navigate. And as you've seen, we've put in some new equipment into that lab in Coventry, and we hope to use it as a hub for our activities in the UK, and also a hub for our academic activities in the UK. All right, guys, I'm going to sign off. I appreciate you guys coming. I know it's not so relevant in Asia, but it's the European Cup final this evening, and England is playing Italy. So for any of our Italian colleagues, I wish you good luck. So Aftab and Ali, thanks very much, guys, and I will speak to you both soon. So take care. Bye bye.